What is a scalar? A scalar is a physical quantity which has only magnitude. There is no direction with it. If there is change in magnitude, the vector changes. If there is change in direction, the vector changes. If there is change in both magnitude and direction, then also the vector changes. If two vectors are acting in the same direction, their magnitude may be equal or may be different. Then they are called as parallel vectors. Hello students, welcome to this first session on the chapter Motion in a Plane from First PU Physics. I am Madhu R from the Department of Physics at Vidhyaashram PU College, Mysuru, your Temple of Excellence. In the previous chapter, we have learnt about motion in a straight line, which was essentially motion in one dimension. Here, under the topic of motion in a plane, we will study about motion in two dimensions. Let us check what it is going to be. Let us begin by understanding what is motion in a plane. Motion of a particle or an object in a plane is essentially motion in two dimensions. Earlier, we used to say motion in a horizontal straight line or a particle which was dropped from the top of a tower or a building downwards or a ball being thrown upwards. So it was essentially motion in one direction, either x-axis or y-axis. Now we shall have motion in two dimensions. A typical example for motion in two dimensions can be a projectile motion. Any object thrown into space is a projectile. Similarly, a circular motion is one of the best examples for a two-dimensional motion or motion in a plane. To understand such types of motions, that is two-dimensional motions, we require something called as vectors. These are mathematical objects which are used to represent these types of motions. So to better understand motion in a plane, we need to completely understand what are vectors, what are its types, and how to operate vectors mathematically. Let us check them one by one. Once I say vector, I will have to invariably understand the opposite part of it, which is nothing but a scalar. What is a scalar? A scalar is a physical quantity which has only magnitude. There is no direction with it. What is the example? Say suppose I define speed. What is the average speed with which you drive your bike? I say it is 60 km per hour. The average speed with which I drive my bike may be 60 km per hour. I don't say in which direction I am driving. So that is only magnitude. There is only value to this, but there is no direction. So examples for such scalar quantities are mass, length, time, temperature, current, work, etc., etc. Okay? Let us now have a look at what are vectors. Vectors are those physical quantities which have both magnitude as well as direction. What is the example? Take for example velocity. What is the velocity of the car that is being driven? Which say the velocity is 15 meters per second in the north direction or in the west direction. So along with the magnitude, we also give the direction to this. That is why such quantities are called as vectors. Physical quantities which have both magnitude as well as direction are called vector quantities. What are the examples? It may be displacement, velocity, acceleration, force, momentum, etc. So all these things are typical examples for vector quantities. Now, what is the difference between scalar and vector? This can be a typical 2-mark question to differentiate between scalars and vectors. Scalars have only magnitude, whereas vectors have both magnitude as well as direction. How to change a scalar? Change in magnitude will change the scalar. How to change a vector? A vector can be changed in 3 ways. If there is change in magnitude, the vector changes. If there is change in direction, the vector changes. If there is change in both magnitude and direction, then also the vector changes. Okay? What are the typical examples? Speed, distance, time are typical examples of scalar quantities, whereas velocity, acceleration, force, displacement, etc. are typical examples of vector quantity. Scalars follow normal algebra or ordinary algebra, whereas vectors follow vector algebra. Okay. Now, what is the exception? Electric current, although has both magnitude and direction, it does not follow triangular law of addition. That is why vector algebra comes into picture. When we move on to triangular law of addition of vectors, we will tell that in detail. How to represent a vector? You are saying it is a vector. How do I write a vector? Okay. A is called as the initial point. See, I have drawn a line here. Okay. A is the initial point. B is the terminal point. I can also call A as tail and B as head. I can also call them as tail and head. Okay. So, A is called the initial point and B is called the terminal point of this vector. The length of this line segment A to B represents the magnitude of the vector, and this arrowhead represents the direction in which this vector is acting. Length of the line segment represents magnitude, arrowhead indicates the direction of the vector. How do I write it on a piece of paper? I can write it with the help of a bold letter. Okay, with the help of a bold letter. Or I can simply write a letter and put an arrow mark on its head. That is also a representation of a vector. Or this line segment is between A and B. So I can write AB and put an arrow mark on its head. So I can represent this vector in three types. A bold letter, a normal letter with a arrowhead, or the letters in between which you have drawn the line along with a arrowhead. This is the method in which I can represent a vector. What are the types of vectors? We have to understand how many types of vectors are there. What are they? The first and foremost is called as a zero vector or a null vector. What does a zero vector mean? Any vector which does not have any magnitude or whose magnitude is zero is called a zero vector or null vector. It is represented by 0 and an arrow mark above its head. There is no magnitude. Okay, there is no magnitude. This is a zero vector, just a point. There is nothing else. Then, after a zero vector, I got something called as a unit vector. What is unit vector? As the name itself suggests, the magnitude is unity or 1. Vector whose magnitude is equal to 1, okay, is called as unit vector. How do I represent unit vector? I represent it by the letter A with a cap. I read it as A cap. So, if I mean that A is a vector, its unit vector will be A cap. Okay. How do I do? I have got magnitude of vector A into A cap will give me vector A. This is vector A. How do I obtain the magnitude? What is the length of this vector? Here it says it is 2.5 units. So, magnitude of a vector A into A cap will give me vector A, or this is 2.5 is the magnitude into A cap will give me vector A. This is what we have written here. So, this is how I represent a unit vector. Magnitude of a vector is also known as the modulus. So, whatever is the length of the vector here which represents the magnitude, it is also called as modulus. That magnitude or modulus is represented by writing the vector within two straight lines. Okay. So, this is a zero vector and a unit vector. Let us check the other types. There is something called as an equal vector. Okay. Now, before going on to that, what are unit vectors along the x, y and z axis? See, I have a vector here. Okay. I have a vector here, some vector A. What is its unit vectors along the x axis? Along the x axis, the unit vector is I cap. Okay. Along the x axis, it is I cap. Along the y axis, it is j cap. Along the z axis, it is k cap. So, along x, y and z axis, it is I cap, j cap and k cap. Now, what are equal vectors? Okay. Two vectors, any two vectors A and B or B and C can be called equal vectors when, if and only if, both of them have the same magnitude, okay, both of them, okay, are in the same direction, are acting in the same direction, and very importantly, both are representing the same physical quantity. If one of these vectors represent force, another vector represents acceleration, then I cannot say that these two are equal vectors. Okay, they may be equal in magnitude and direction, but they are representing different physical quantities. So for two vectors to be equal, they have to be equal in magnitude, they have to be acting in the same direction, and they have to represent the same physical quantity. Only then they can be called as equal vectors. Next, what is a negative of a vector, or what is opposite of a vector? You can also call it that way. A vector equal in magnitude but opposite in direction. Okay, one is acting in this direction, other one is acting in this direction. So a vector equal in magnitude but opposite in direction to the given vector is called as a negative of a vector. If this is A, this is minus vector A. Is that understandable? Now we come to something called as concurrent vectors. What are concurrent vectors? Two vectors which originate from the same point. Suppose this is acting from the same point O. This is vector A, this is vector B. They start from the same initial point, or they are connected by their tails. Then they are called as concurrent vectors. Okay, if they have the same initial point, or if their tails meet each other, then they are called as concurrent vectors. Now let us go to another concept which is called as coplanar vectors. Suppose we are acting in one plane, this is y and this is x. If two vectors are acting in the same plane, this is vector A and this is vector B, okay, which are acting at an angle theta to each other. Since they are acting in the same plane, I can call them as coplanar vectors. Any vectors lying in the same plane are called as coplanar vectors. Now coming to another point, which is parallel vectors. What are parallel vectors? If two vectors are acting in the same direction, their magnitude may be equal or may be different, then they are called as parallel vectors. If two vectors are acting in different directions, then they are called as anti-parallel or non-parallel vectors. Okay, if two vectors are acting in the same direction, okay, their magnitude may be equal or not, they are called as parallel vectors. Two vectors acting in different directions are called as anti-parallel or non-parallel vectors. Now let us try to understand how vectors can be mathematically operated. What are the operations that can be done on vectors? First is addition of vectors. Okay, what is addition? Two vectors of the same nature. Okay, what do you understand by same nature? They have to represent the same physical quantity. They have to represent the same physical quantity. So two vectors representing same physical quantity in the same unit. I cannot have one vector representing velocity in kilometer per hour and another vector representing velocity in meter per second. Okay, then I cannot compare them or add them. I cannot do any mathematical operation. So two vectors which represent the same physical quantity and have the same unit can be added with the help of two rules. Okay, I can add two vectors when they are representing the same physical quantity in the same unit by two methods. What are those? The first one is the triangular law of vector addition. First one is triangular law of vector addition. What does it say? The triangular law says if two vectors A and B are represented by two sides of a triangle, see, one vector A, one vector B. Suppose this triangle is ABC represented by side AB. Vector A is represented by side AB. Vector B is represented by side BC. So two vectors A and B are represented by two sides of a triangle in head to tail form. See, this is one vector A. The head of first vector joins the tail of second vector. This is vector B, head to tail form. Then the closing side of the triangle then the closing side of the triangle taken from tail of the first. See, this is the tail of the first vector. This joins the head of the second vector. Okay. Then this third side represents the resultant or the sum of the two vectors. The resultant will represent both in magnitude and direction the sum of two vectors A and B. Okay. Let us check once again how it works. Let two vectors A and B be represented both in magnitude as well as direction. So the length of this line represents the magnitude of vector A. The length of this line represents the magnitude of vector B. Two sides of the triangle in head to tail form. Please remember, this is head to tail. The head of first vector connects to the tail of the second vector. Okay. Then their resultant R is equal to A plus B is given both in magnitude as well as direction by the third side of the triangle, which is AC. Here, the tail of the resultant is connected to the tail of vector A and the head of the resultant vector is connected to the head of vector B. So that resultant is given by R is equal to A plus B both in magnitude as well as direction. So this was one way how you could add vectors. What is the second way in which I can add vectors? It is parallelogram law of vector addition. By the help of parallelogram law of vector addition, I can add two vectors. What does it say? It states that if two vectors can be represented in magnitude and direction by the two adjacent sides of a parallelogram. See, I have two adjacent sides of a parallelogram. This is one side represented by vector A. This is another side represented by vector B. Now the diagonal which connects from the same initial point. See, this is a tail to tail connection. This is a tail to tail connection. The tail of vector A and the tail of vector B as well as the resultant's tail all originate from the same point. All of them are concurrent vectors also. Okay. So the diagonal which starts from O and connects to C, this will be the resultant of the two vectors, both in magnitude as well as direction. It states that if two vectors can be represented in magnitude and direction by two adjacent sides of the parallelogram drawn from a single point, the resultant vector is represented by the diagonal of the parallelogram passing through that same point. Okay, so that will be the resultant. Now I have added one more small concept here, which is the equilibrant. What is the equilibrant? Equilibrant is the negative vector of the resultant. Okay, so it is equal in magnitude to the resultant, but it is traveling in the opposite direction or acting in the opposite direction. We will use the concept of equilibrant in laws of motion. Okay, please remember that the opposite or negative vector for the resultant will be the equilibrant. Okay, let us check this parallelogram. I have got two sides of the parallelogram, OA and OB, representing vectors A and vectors B. They are starting from the same point. They have got the same initial point, or they have got the same tail. Two vectors A and B be represented both in magnitude and direction by the adjacent sides OA and OB of the parallelogram, OACB. Then their resultant R is given both in direction as well as magnitude by this diagonal, which is drawn from the same initial point and connects the opposite sides of the parallelogram. This diagonal OC represents the resultant. So resultant is given by vector A plus vector B. This resultant, both in magnitude as well as direction, is represented by this diagonal line. Okay, so we have got two methods of addition of vectors. One is the triangular law, the other one is the parallelogram law. Let us now check how the resultant of two or more vectors can be expressed with the help of an equation. Okay, the resultant of a number of vectors is that of a single vector. Okay, you can express a number of vectors in terms of a single vector, which produces the same effect as the net effect of all those individual vectors. Say for example, two vectors are acting like this, vector A and vector B at an angle theta. Obviously, we know that with the help of parallelogram, law of addition of vectors, I can find the resultant like this. This is the resultant, both in magnitude as well as direction. What is the direction? The direction is given by alpha with respect to the horizontal. Okay, I will not be able to measure the length so that I can find the magnitude of the vector. I will not be able to measure the angle so that I obtain the direction. So in that case, what can I do? I can go back to the equation. What does the equation say? The resultant of two vectors A and B is given by R is equal to square root of A square plus B square plus 2AB into this angle theta, cos of that angle theta. How can I obtain the direction? The direction alpha is given by tan inverse of B sin theta by A plus B cos theta. So I can find the resultant of any two vectors both in magnitude as well as direction with the help of these two equations. Now what are the properties of addition? Okay, vector addition follows a commutative law, which means that I can add A and B. Any one of them can be first, the other can be the second. A plus B is equal to B plus A. This is called as a commutative law. Vector addition will also follow associative principle. What does that mean? A plus B plus C is equal to A plus of B plus C. It follows both the commutative law as well as associative law. Now moving on, let us check if vectors can be subtracted. We have seen how vectors can be added. Let us check how vectors can be subtracted. Vector subtraction also follows the principle of vector addition. See, I got one vector A and one vector B. This is vector A, this is vector B. By the principle of triangular law of addition of vectors, AC will give me the resultant. This resultant will be A plus B. Vector A plus vector B. Similarly, I have got one vector here, another vector here. Please observe, whatever is the magnitude of vector B, I have got a vector with the same magnitude, but the direction is opposite. So this becomes negative of vector B. So when I add these two, A plus of minus B, the resultant will become vector A minus vector B. Suppose vector A is 3, vector B is 7, I get the answer as 10, A plus B. Suppose vector A is 10, B is 3, in the opposite direction, which is 10 minus 3, I will get it as 7. So I can do subtraction of vectors in this fashion. What do I do? Subtraction of a vector B from vector A is defined as the addition of minus B. So what do? I take the negative vector of that vector. Thus A minus B is equal to A plus of minus B, which is nothing but the resultant R. This is how I can subtract a vector. Can I multiply a scalar with a vector? Yes, I can do it. Vector multiplication by another vector will come at a later stage. For now, let us try to understand how I can multiply a scalar with a vector. Multiplication of a vector with a real number gives a vector. What is a real number? A real number is a scalar quantity. It has only mass and no direction. So this multiplication is also called as a scalar multiplication of a vector. Vector A is multiplied by 3. What will be the resultant? The resultant will be 3A. You can observe here, I have got a vector V. I multiply that with a negative number minus 3. Then the length of the arrow will be 3 times the length of vector V. Please observe, because it is minus vector V, okay, or minus 3, the direction of the arrow changes. It acts in the opposite direction. So, if you are multiplying a vector with a scalar which is a negative in nature, the direction of the vector will change. If this was A, this will be minus 3A. What is a typical example of scalar multiplication of vector? See, we know that force equals mass into acceleration. Acceleration is a vector, mass is a scalar. So once you multiply the mass of the object with the acceleration, you get a multiplied factor of a vector with a scalar quantity. A is multiplied with a negative number, then the direction will be opposite to that of A. This is how we do multiplication of vectors. What did we do in today's class? We tried to understand what is motion in a plane, which was a two-dimensional motion. We understood that to understand a two-dimensional motion, we require something called as vectors. So we initially studied what is a scalar, what is a vector. We tried to differentiate between scalars and vectors. We tried to understand the types of vectors and the operations that can be conducted on a vector: addition, subtraction and multiplication. For addition, we understood that we can add two vectors by following either the triangular law or the parallelogram law of vectors. One follows a head to tail concept, the other follows a tail to tail concept. Okay, by this we come to the end of this session. Have a wonderful learning experience. Thank you.